Hello, good morning class. I am Ma'am Saibal Gigante again, your science teacher in grade 7. Today, we are going to learn another interesting lesson again in science, specifically in physics. Wanna know what is our topic for today? Let us watch this video. Alright, the video is done. What have you watched? Very good. It's kids relay game. What are they doing? Exactly. They are running. Who runs the fastest? Of course, the girl who wears blue shirt. Now, what is your idea of speed? How about velocity? Alright, we will find out later if your ideas of speed and velocity are correct. Class, our lesson for today is speed and velocity. We are going to use a little bit of math in this lesson. For those who love math, you are going to really enjoy this topic. For those who don't love math, don't worry, we will make things easier as well as funnier for you, so you can still enjoy while learning. Here are the objectives of our lesson. These are the things that we must achieve after the discussion. After this lesson, you should have already differentiated speed from velocity. Number 2, calculated speed and velocity of a moving object. And number 3, created a campaign on disaster risk reduction through different mediums. Sounds interesting, right? Okay, let us start with picking your favorite color. For those who love green, raise your hand. I only need 7 learners. Okay, for those who love red, raise your hand. Only 7. For those who love lavender, raise your hand. Only 7. And for those who love orange, raise your hand. Only 2. Alright, we are done with picking your color. Let us now find out what is the role of each color. Okay. We have our activity number 1. The title of this activity is Fun Walk. For those who picked green, you are the timekeeper. For those who picked red, you are the time and distance recorders. For those who picked lavender, you are the participants of Fun Walk. And for those who picked orange, you are the distance markers. Okay, we have here the procedures for our activity so that our activity is organized. Procedure number 1, have the distance marker measure the distance of 5 meters from the starting line to the ending mark or finish line using tape measure. I will be giving the distance markers the tape measure. Mark on the ground the starting line and the finish line using the flaglets. And I will be giving to you also the flaglets. These are the flaglets, the red and the blue. The blue one, you will put this at the starting line. And the red one, you will put this at the finish or end line. Gets? Okay. Procedure number 2. Each participant of Fun Walk, timekeeper, and recorder will be given a specific number to identify themselves. Numbers 1 to 7. So that means I will be giving the participants a number 1, 2, 3, 4, 5, 6, 7 numbers. For timekeeper, I will be giving them 1 to 7 also, and to the recorders 1 to 7 also. I have here the numbers. The numbers from number 1 up to number 7. I have so many numbers. Up to number 7. So that means I will distribute these numbers to each participant and each timekeeper and each time recorder randomly. Okay? So, participants, timekeeper, and time recorder, you are going to put the number that is assigned to you at the back. Sorry, at the back. But I think it is much better if you put it in front of you. Okay, in front na lang. Okay, you are going to put this using the scotch tape in front of you. Procedure number 3, each participant has both a timekeeper and time recorder. They are grouped according to their number. So that means, say for example, participant number 7, your time recorder is time recorder number 7, and your timekeeper is timekeeper number 7. The same also with another number. So that means you are grouped according to your number. Okay? Procedure number 4, the two markers will serve as observers of the activity. Okay, markers after you have marked the ground, because we are using the field for this activity so you can move freely. After you have marked the distance and you have put the flaglets at the starting line and the finish line, you are going to stay behind to observe the participants. Procedure number 5, refer to the chart of fun walk to recognize the arrangement of the fun walk. So this is the arrangement of our fun walk. As you can see here at the bottom, you can read here the P1, P2, P3, P4, P5, P6, P7. They're not money, they are the participants. Just kidding. P1, participant number 1, P2, participant number 2, P3, participant number 4, and up to P7, the participant number 7. As you can see, all the participants are standing at the starting line. Where is the blue flaglet? Where is the flaglet? Is standing. Oh, alright. We'll be using stick for each flaglet so they can stand. At the right side, I have used different colors for each number so you can easily identify your arrangement. Timekeeper number 1, next to you is recorder number 1. Timekeeper number 2, next to you is recorder number 2, and so on and so forth. At the left side are the two color gray lines. So these are the markers. You are going to stay there and observe the 7 participants as they walked. Okay, clear. Procedure number 6. After everything is arranged, have the participants get ready at the starting line. Once the participants hear the word go from the teacher, from me, that is the only time that they should start walking. Procedure number 7. Timekeeper will keep their eyes on their watch and to the participant assigned to him or her. So that means timekeeper number 1 will watch the participant number 1. And timekeeper number 2 will watch the participant number 2. The same with the other numbers. Once the participant has reached the finish line, the timekeeper will tap stop on their stopwatch. He will then tell the time to the recorder. So for the timekeepers, don't worry, I am going to provide you the stopwatch. Procedure number 8, recorder will record both the time of the participants as well as the distance. After getting the time and distance, recorder will now divide time from distance to get the participant's speed. Procedure number 9, when the data is all ready, recorder will show to the class the result of fun walk through filling out the table on the board. This is our table. I will be posting this to the board, on the board, I mean. So, under the P1, you have here the time. Recorder number 1 will record here the time of participant number 1. The same with participant 2 and 2 to 7. Recorder 2 to 7 will record their time under the specific number, under their number. Okay, clear. After putting or filling out the time, you have to put also the speed at the bottom. Okay. Procedure number 10. Two observers will then come in front of the class, that is the markers, and tell them their observations using these guided questions. These are the questions that the two observers or the markers should answer. Who walks the fastest? What is the speed of the participant who walks the fastest? What can you conclude about speed? Okay, clear. Are the procedures clear? Okay, clear. Let us now work on our activity number 1. Alright, our activity number 1 is done. This is now the result of our fun walk. Participant number 1 got 50 seconds. Participant number 2, 40 seconds. Participant number 3, 25 seconds. Participant 4, 55 seconds. Participant 5, 60 seconds. Participant 6, 18 seconds. And participant 7, 35 seconds. Now, who walks the fastest? Very good. The participant number 6. Very good. Because he has 0.3 meter per second speed. Now, what can you conclude about speed? Okay, we will find out later. Let us have this another activity. The title of this activity number 2 is How Was the Weather? These are the procedures. Okay, I will divide the class into 2. Each group should select one representative. Each representative will be given 2 minutes to read the weather bulletin presented to the class. Okay, this is the weather bulletin. Procedure number 4, each representative will then act as a weather forecaster in front of the class. And after forecasting, each representative should answer the guided questions. These are the guided questions. What is the location of center of Typhoon Yolanda? What is the strength of the winds of Typhoon Yolanda? What is the movement of Typhoon Yolanda? And what can you conclude about velocity? Are the procedures clear? Clear. Okay, let us now work on our activity number 2. Alright, activity number 2 is done. Okay, what is the location center of Typhoon Yolanda? Very good. 975 kilometers southeast of Tacloban City, Leyte. Okay, what is the strength of the winds of Typhoon Yolanda? 280 km per hour to 335 km per hour. Now, what is the movement of Typhoon Yolanda? Exactly, 35 km going west-northwest. Now, what can you say about velocity? Alright, we will find out later if your idea of velocity is correct. Okay, let us have this triangle speed formula or CDOT because I will be giving you a problem solving to be solved so I can see how far have you reached in solving the speed and velocity. Triangle speed formula shows the formula in getting the distance, time, and speed. Okay. Anyway, just to get rid of confusion, we will be using small letter S for speed and small letter V for velocity. Small letter T for time and small letter D for distance. Okay, the formula for distance is speed times time. Time is distance divided by speed, and speed is distance divided by time. Okay, from this triangle speed formula, you are going to answer this activity number 3, our seat work. Okay, I will be giving only 2 minutes to answer this problem solving. They're just easy. Okay, 2 minutes is over. And thank you, representatives, for answering. Let us find out if your answers are correct. For problem number 1, our problem number 1 is, what is the speed of the tortoise if it took 6 hours to travel 3 kilometers? The given is, R, time 6 hour, distance 3 kilometer, and we are going to solve for speed. What is our formula for speed? Distance divided by time. Okay. What is our distance? Our distance is 3 kilometer and our time is 6 kilometer. 3 divided by 6 is 0.5 kilometer per hour. Always remember that the partner of kilometer is always hour and the partner of meter is always second. Okay. For problem number 2, what is our problem number 2? A Philippine Airlines plane regularly take off from Manila at 5:30 a.m. and expected to land in Zamboanga, 852 kilometers south of Manila at exactly 7:30 a.m. What should the average velocity of the plane be if it is to land Zamboanga City on time? Okay, we have here the given. Time is 2 hours since it is 5:30 to 7:30. 5:30, 6:30, 5:30, 6:30, 7:30. So our time is 2 hours. Distance 852 kilometer south. What is our formula for getting the velocity? Of course, the same with the speed. It is distance divided by time. Okay. We have the distance 852 kilometer and the time 2 hours. Let us just divide it. Our velocity is 426 kilometer per hour south. Now, what can you say about speed and velocity based from the answers on the problem? Let us now, this is the time to elaborate and explain the speed and velocity. What is speed? Okay. You have answered a while ago. Your answers a while ago are all correct. When we say speed, it is the term used to describe the distance traveled per unit time. It does not indicate direction or change in direction. It describes the rate of change of position, and speed is scalar quantity. When we say scalar in science, it describes only the number and a unit of measurement. Say for example, 350 kilometer per hour. That is speed. 320 meter per second. That is speed. Because when we say speed, we are just talking about the number of how slow or how fast the moving object is. Okay? So we have two types of speed, the constant speed and the instantaneous speed. When we say constant, from the word itself, constant, the speed is the same throughout the travel. Okay. Say for example, the beginning speed is 2 meter per second, and after, say for example, 3 minutes, it is still 2 meter per second. After 5 minutes, it is still 2 meter per second. And after 6 minutes, it is still 2 meter per second. That is constant speed. The speed is not changing. It is always the same throughout the time. How about instantaneous speed? Instantaneous speed changes every time. When we say instantaneous, the speed is changing over time. Say for example, the beginning speed is 2 meter per second, then after 1 hour it became 5 meter per second, and after 1 hour it became 10 meter per second. That is instantaneous speed because it is changing. The speed changes. Okay, gets? Alright. How about velocity? Velocity, similar to speed. Velocity is similar to speed. That is why the formula for getting the velocity is still the same with the speed. But the only difference is that velocity is a vector quantity. When we say vector in science, it describes both the magnitude and direction. So it does not only describes how fast or how slow the moving object is, it also tells us the direction of the object. Okay, what are our different directions or locations? We have north, south, east, west, northeast, northwest, southeast, southwest, and so on and so forth. So say for example, 352 kilometer per hour south, that is velocity. 360 meter per second, wow, ang bilis. 350 meter per second north, that is velocity. Gets? Clear? Clear. Clear. Is everything clear? Okay, clear. Let us now have this triangle speed formula again. Okay, the green here, the color green here indicates the missing one. So that means if the distance is missing, the formula for getting the distance is just speed times time. And if the time is missing, the formula is distance divided by speed. And if the speed is missing, the formula is distance divided by time. I know that you are already familiar with this triangle speed formula, and we are going to use this to solve this. I will only give you 5 minutes to answer the table using our CDOT or triangle speed formula. Right, so solve for the missing variable and solve for the missing variable only. Sorry for the typo error. We have there the speed and velocity at the second column. The third column the time or the letter T. And the last column, we have the distance or the letter D. For number 1, you are going to get the distance. For number 2, you are going to get the velocity. And for number 3, you are going to get the time. Clear? Alright, so let us start solving. 5 minutes is over. Let us check if your answers are correct. For number 1, our distance is 1,600 kilometers. Why? Because the formula for distance is speed times time. What we are going to do is just multiply speed to the time. Our speed is 40 km per hour and our time is 40 hour. We are going to cancel the same unit, which is hour. The answer is 1,600 km. For number 2, our time is, for number 2, what is the missing? Speed. The missing is velocity. What is the formula for velocity? It is the same with the speed, distance divided by time. Our distance is 150 kilometers southeast. Our time is 50 hour. Distance 150 divided by 50 hour. The answer is 3 km per hour southeast. Remember to always put the direction after your answer for the velocity. For number 3, the time. What is the formula for the time? Distance divided by speed. What is our speed? 20 km per hour northwest. It is a velocity. 20 km per hour northwest and our distance is 80 km. 80 km divided by 20 km per hour. The answer is 4 hour. 4 hour, the unit is hour because we have cancelled out the same unit, which is kilometers. Kilometer. So the answer is 4 hour. Any questions? Alright, so let us have a volunteer to answer this problem solving number 1. Okay, thank you so much, volunteer. Let us check your work. What is our problem? Iman walks 7 km east in 2 hours. What is the man's velocity? Given distance is 7 km, our time is 2 hours, and we are looking for velocity. What is our formula for velocity? Very good. Distance divided by time. So here is our solution. What is our distance? 7 km and our time is 2 km. 7 km divided by 2 km is 3.5 km per hour. So we have forgotten here the direction. The answer is 3.5 km per hour east. Clear? So let us have this sample problem number 2 again. Any volunteer? Okay, thank you so much, volunteer. Let us check if your answer is correct. What is our problem? If I can walk at an average speed of 5 km per hour, how many kilometers I can walk in 2 hours? The given speed is 5 km per hour, time is 2 hours, and distance is missing. What is our formula for distance? Speed times time. Let us have the solution. Distance equals speed times time. Our speed is 5 km per hour times 2 hours. Cancel out hour. Cancel out hour. The answer is 10 kilometers. Okay, very good. Any questions? Any questions? None? If there is none, I have only one question for you. What is the difference between speed and velocity? Very good. Velocity has both the magnitude and direction, while speed has magnitude only. I think you have learned so much from this lesson. It is now the time for me to evaluate what have you learned so far by doing this evaluation. For test 1, using the Venn diagram. Okay, anyway, get one whole sheet of paper and let us answer the evaluation to evaluate the learnings you have gained from this lesson, to see if you have learned something from this lesson. Okay, ready? Ready. For test 1, using the Venn diagram, compare and contrast speed and velocity. So here you are just going to compare the speed from velocity using the Venn diagram. Okay, questions? Clear? Okay. For test 2, you are going to solve the following problems. You should identify the given and show your solution. For number 1, the problem is a car travels from point A to point B with a distance of 500 km north within 5 hours. What is its speed and velocity? Problem number 2, if a motorcycle has a speed of 100 meters per second, how far it will travel in 500 minutes? And how long it will take to travel a distance of 500 meters? Okay, I will only give you 10 minutes to answer the evaluation. Alright, 10 minutes is over. Pass your paper to the center aisle and then forward. Okay, thank you so much, learners, for participating. I hope that you have learned something. As I look at your test, as I look at as I look at to your papers, I have seen that most of your answers are correct. Let's clap our hands. Let us have now the extend. This is the last part or last activity in this lesson. The title of this activity is Safety Along the Roads. With the many road accidents daily, road users must be well informed on the road safety so as to put themselves or others at risk. So as not to put themselves or others at risk. Using the Safety Along the Roads information sheet provided by the teacher, provided by me, I will be giving you the Safety Along the Road sheet. Create a campaign on disaster risk reduction through any of the following: slogan, poster, poem writing. Poem writing is free verse, quatrain, and 3-paragraph essay writing. Choose only one preference. A rubric is provided for each preference. So for those who like slogan, you can choose slogan. For those who like poster, you can choose poster. And for those who like writing, you can choose either poem writing or paragraph essay writing. Here are the objectives for each, the rubrics for each preference. The rubric for the slogan and poster, we have the craftsmanship, creativity, and originality. All in all, 5, 10, 15 points. 5, 10, 15 points. For poem writing and essay writing, we have the focus or main point, the organization, the language, and the originality. Okay, that is the end of our lesson. Don't worry, the rubrics is provided in the Safety Along the Road sheet that I will be giving to you. Okay, that's the end of our lesson. I hope you have learned something. Okay, class dismissed.